Welcome back, everyone. Once again, this is Professor Sebastian. We are on page 54 of our statistics class notes, and then we're moving into the class notes for section 4.3 about modeling linear trends. And really, this is moving forward with regression analysis. So far, all we've really learned about regression analysis is to look at a scatter plot, see what the trend looks like, whether it's strong or it's weak, right, for strength, and then also see the shape, whether it's linear or nonlinear. We will only work with linear models in this course. Okay, so we get more information though when we do a regression. We actually get a regression line, and you've seen that already, and I've made reference to it a little bit in our examples. But StatCrunch will actually fit this nice perfect line through it, and it will actually give you the equation of the line. And I'll show you that in an example later. But right now, just let's look at the line. And again, when it fits this, it's a mathematical fit to it because it's minimizing the distances from each dot summed up, the distance from each dot to the line summed up, and it minimizes that. It's a calculus-based problem, so it's not anything you need to know how to do, but just know that that is the best fit line through that. You cannot get a better line through those dots that correlates them. Okay, so what is a regression line though? It's a tool for making predictions about future observed values, right? So let's say this example here shows a number of years in school compared to hourly wages. So if we were to ask the question, okay, if somebody in the future goes to school for 10 years, about what could they expect for an hourly wage rate? This is back old data from 1970. So this is the minimum wage was really low, but compared to now, but somebody worked 10 hours, you come up to the line, you come across, they could expect to make like $2.75 an hour, etc. That's a prediction of future observed values. Now remember, the form for the equation of any line is y equals b plus mx. Now most of you are comfortable with y equals mx plus b. You could probably spit that right back at me. I just gave it in the form of b, the y-intercept, plus mx, where m is the slope, because that's the form that StatCrunch gives it back to us in. It doesn't matter when you add things what order they're in. So that's the order it gives us to. All right, so again, back to our scatter plot here. Hopefully everyone would agree with me that that's a pretty strong, positive, and linear trend. The R value, the correlation coefficient, comes out actually to be 0.883. So again, that also tells us that we were, good in our assumption that that's pretty strong because it is close to 1. The positive trend indicates that people who stay in school longer, in other words, as X increases, as the number of years in school increases, or as this sentence says, who stay in school longer, tend to, always stick those words tend to in because it's not true for every data value, tend to have higher rate of pay. Okay? As X increases, Y tends to increase or decrease, in this case increase. Okay, example 66. Let's say we were looking at mileage in thousands on a car compared to the price of used cars in thousands. So this is the number of miles in thousands. So this would be 60,000, 70,000, etc. miles that the car has been driven. And then these are the prices of the car in thousands: 11,000, 12,000, 14,000, 15,000, 16,000, etc. So that's kind of weak. It's negative. You can see that as X increases, right, as the number of mileage on the car increases, its sales price tends to decrease, right? The regression equation comes out to be, and I put a decimal in the note, sorry, that's a comma, it's 15,000, but the regression equation comes out to be price equals 15,867 minus 0.034 miles, right? Price is the Y, so Y equals B, the intercept, plus mx. So we have a negative slope. Then the slope is negative. We have a negative correlation. Okay? So we're going to use this regression equation to predict the sales price of a car that has 62,000 miles. That just means you let x be 62,000, you plug it in there. So miles is 62,000. You plug it in, you put this in your calculator, 15,867 minus 0.34 times 62,000, which was X. You come out to be $13,759. That's what you would predict the price of the car to be. Be careful when you're looking at this graph. It doesn't look like the y-intercept's at 15,867 because notice it's neither the x nor the y are starting at 0. So you really can't see the y-intercept on this graph if that was confusing you.